Hello students, we are going to continue with our chapter circles. Let us revise our concepts which we had studied in our earlier session. First, a tangent. A tangent to a circle is a line that intersects the circle at one point. This one point is P. So, this is the one concept we had done earlier in the session, and now second is the tangent at any point on the circle. The tangent at any point on the circle is perpendicular to the radius through the point of contact. This is a 90-degree angle. So, let us move forward. We have some examples to do now. We have the first example. Prove that in two concentric circles, the chord of a larger circle which touches the smaller circle is bisected at the point of contact. We have the figure here. We have C1, the larger circle. We have C2, the smaller circle. O is the center of the circle. AB is the chord on C1, the larger circle, and P is the point of contact of the tangent AB on C2. So, given is two concentric circle C1 and C2. Then at the center O, the chord AB of the larger circle, chord AB on the larger circle C1 touches the smaller circle C2 at the point P. What we have to prove? We have to prove that AP is equal to PB. AP is equal to PB or BP. Let us join OP. This is the first step. The first step is let us join OP. I am joining OP, right? And then AB is a tangent to C2. AB is a tangent. So, what is this angle? This angle is a 90-degree angle. This is angle 90 degree. So, also AB is a chord of the circle. Now, let us see another theorem. When AP is a perpendicular on the chord AB, then AB is bisected by that perpendicular. We have proved that OP is a perpendicular. Now, since OP is a perpendicular on the chord AB, OP bisects AB. Then we have AP is equal to BP, right. So, I hope this is clear. AP is equal to BP. The only concept what we have used is OP. Since OP is the radius and AB is the tangent, OP is perpendicular to AB. Let us do some more examples. Here we have the second example. Two tangents TP and TQ are drawn to the circle with center O from an external point T. Prove that angle PTQ is equal to twice of angle OPQ. So, what we have is this angle is twice of this smaller angle. We have to prove this. Given is a circle with center O, we have a circle center O and an external point T. This is the external point T, and from T we have two tangents TP and TQ. TP and TQ, where P and Q are the point of contact on the circle, right. So, we have to prove that this angle PTQ is twice of angle OPQ, the smaller angle. Now, by the theorem 10.2, what does the 10.2 theorem say? TP is equal to TQ. Why? Why is TP equal to TQ? Because from an external point T, when we draw two tangents to the circle, the tangents are equal in length. So, TP is equal to TQ. We have this. Now, TPQ is an isosceles triangle. This triangle, TPQ, this is an isosceles triangle wherein this side is equal to this side. Since the two sides are equal, the angles will be equal. So, this angle will be equal to this angle. So, angle TPQ is equal to angle TQP, and that is equal to half of 180 minus theta, the whole half of 180 minus theta, which comes out to be 90 degree minus half of theta. Theta is this angle and this angle comes out to be 90 degree minus half of theta. Now theorem, what does theorem 10.1 say? Theorem 10.1 says angle OPT, or I can say angle OPT. This angle, complete angle, is 90 degree. Similarly, you can also draw here. This angle is also 90 degree. Why are these two angles 90 degree? Because the radius makes an angle of 90 degree with the tangent. So, angle OPT is equal to 90 degree. Now, angle OPQ is equal to angle OPT minus angle TPQ. How? What is this angle? This angle is this complete angle, right, minus this angle. OPT minus QPT makes the smaller angle, right. So, this angle is 90 degree minus this portion, 90 degree minus half of theta, and we have half of theta. Why? Because 90 degree and 90 degree cancel each other, and we have half. What is half of theta? Theta is this angle PTQ. This is theta. So, we have what is half of theta? Half of theta is angle OPQ, and we have proved the question. Angle PTQ is equal to twice of angle OPQ. I hope you have understood this. Let us move forward. Example number 3. Prove that tangents drawn at the end of the diameter of the circle are parallel. Here you can see the circle. We have two tangents P and Q. So, we have a circle where the diameter is AB, center is O, and P and Q are the two tangents, right. Now, OA is the radius. Since OA is the radius and P is the tangent, then this angle is 90 degree. This angle is 90 degree. Similarly, this angle is again 90 degree. Why? Because the radius forms an angle of 90 degree with the tangent at the point of contact. So, this angle is also 90 degree. Now, since both the angles are 90 degree, what we can say is angle 1 is equal to angle 2. So, we have angle 1 is equal to angle 2 is equal to 90 degree. So, angle 1 and angle 2 also form alternate in angles, alternate interior angles. Since these two are equal, therefore, P is parallel to Q. P is parallel to Q, and this is what we had to prove, right. So, let us move forward. This is example number 4. The length of the tangent from a point A at a distance of 5 centimeter from the center of the circle is 4 centimeter. Find the radius of the circle. What we have is AO is 5 centimeter, AP is 4 centimeter. We need to find OP, this distance. So, what is given is a circle with center O, and OA is 5 centimeter, AP is 4 centimeter, and OP is the radius. Again, this angle is 90 degree. Why? Radius forms an angle of 90 degree with the tangent. So, this angle is 90 degree, and right, this triangle is a right angle triangle, and we can put Pythagoras theorem on it. So, we have 5 square is equal to 4 square plus OP square. So, we have 25 is equal to 16 plus OP square. So, OP square is 9. What is OP? Square root of 9, that is 3 centimeter. So, we have OP, the radius, as 3 centimeter. I hope it is clear. Let us move forward. This is example number 5. A quadrilateral ABCD is drawn to circumscribe a circle. Let us see the figure. We have to prove that AB plus CD is equal to AD plus BC. What is AB? This is AB plus CD is equal to AD plus CB. So, let us see the proof. AP is equal to AS. What is AP? This is AP. AP is equal to AS. Why are these two equal? Because A is an external point and we have two tangents AP and AC on the circle. We have two tangents AP and AS on the circle. So, AP is equal to AS. Similarly, BP, this one, BP is equal to BQ. Again the same reason. Similarly, CR is equal to CQ, CR is equal to CQ, DR is equal to DS. Now, we need to add all these four. We will add all these four. So, we have AP plus BP plus CR plus DR is equal to AS plus BQ plus CQ plus DS. Just combine these two, AP plus BP, then CR plus DR. Why are we combining these two? Because AP plus BP forms AB, right? Similarly, we will add CR and DR, then AS plus DS, BQ plus CQ, and we have AB plus CD is equal to AD plus BC. So, we have proved this. We have example number 6. Two tangents PQ and PR are drawn from an external point to a circle with center O. Prove that OQRP is a cyclic quadrilateral. So, we have to prove that OQPR, this is a cyclic quadrilateral. Since PR and PQ are tangents, we know that P is an external point, PR and PQ are two tangents from the point, then PR is equal to PQ, right? PR is equal to PQ. Also, OR is a radius and OQ is also a radius, and when we have a radius and a tangent at the point of contact, then we have a 90-degree angle here and a 90-degree angle here. So, we have angle ORP, this angle is equal to angle OQP, that is this one, we have as 90 degree. Now, angle ORP, that is this angle plus this angle plus this angle is 180. Why 180? Because each one of them is 90 degree. So, this angle plus this angle is 180. Now, we see that OQPR, this is a quadrilateral, and what is the sum of angles in a quadrilateral? It is 360 degree. Since these two angles are 180, these two angles have 180 as their sum, then what is the sum of this angle and this angle? That is, see, angle ORP plus angle OQP plus angle ROQ plus angle QPR is equal to 360. So, since these two angles are 180, therefore, we have 180 plus angle ROQ plus angle QPR is equal to 360. So, what we get is this angle plus this angle is equal to 180. And what is the property of a cyclic quadrilateral? If sum of opposite angles in a quadrilateral is 180 degree, then the quadrilateral is a cyclic quadrilateral. Hence, this quadrilateral OQPR is a cyclic quadrilateral. Why? Because opposite angles have their sum as 180 degree, right? This is a property of a cyclic quadrilateral. I hope it is clear. So, let us move forward to our next example. Example number 7. In figure, AB and CD are two tangents common to two circles of unequal radii. We need to prove that AB is equal to CD. So, what are we given here? We are given a circle, this one, circle 1 and circle 2, and we have been given two common tangents. Two common tangents are AB and CD. So, what we need to prove is, we need to prove AB is equal to CD. This point is equal to this one. The first step, we need to construct what? Just extend AB to P, okay, and also extend CD to P. Then we have P as an external point, and we have two tangents, PA and PC is a tangent to the circle 1, right, and we have PB and PD are the two tangents to the circle 2, right? So, what we have? PA is equal to PC, PA is equal to PC, length of the tangents, right? Also PB is equal to PD, PB is equal to PD, again the same reason, length of the tangents from the external point P. So, PA minus PB is equal to PC minus PD, that we get is AB is equal to CD, that is this complete minus this portion, this complete minus this portion, and we get AB is equal to CD. I hope it is clear, right? So, let us move to the next example. Example number 8. Prove that the tangents drawn at the end of the chord of the circle makes equal angle with the chord. So, what we have is RQ is a chord, RQ is a chord. So, we have a tangent at R, we have a tangent at Q. What we need to prove is angle 1 is equal to angle 2. The first step is take any point P again on the circle, join PQ and join PR, okay? Join PQ and join PR. Then what we have? RQ is a chord to the circle, tangents are drawn from the point R and Q, then P is another point on the circle and we are joining PQ and PR. Since a point Q, there is a tangent, we have a tangent at point Q, right? This is a tangent. Then angle 2 is equal to angle P. Why? Alternate segment angles. These are equal angles in the alternate segment. So, angle 2 is equal to angle P. Similarly, since R is the tangent to the chord RQ, so angle 1 is also equal to angle P. Here, angle 1 is equal to angle P. What do you get from here and here? Clearly, angle 1 is equal to angle 2 is equal to angle P. So, we have angle 1 is equal to angle 2, angle 1 is equal to angle 2. That is all what we have to prove here, right? So, let us move forward. This is example number 9. If a hexagon, we can see the hexagon, if a hexagon A, B, C, D, E, F circumscribe a circle, prove that AB plus CD plus EF is equal to BC plus DE plus FA. So, let us prove this. Again a very easy question, the same concept we are going to use is, we have two tangents, again tangents from the exterior point. Let us see, first one, AQ is equal to AP. What is AQ? This is AQ. This is equal to AP. Similarly, these two tangents are equal, these two tangents are equal, these two tangents are equal. All the two tangents are equal. See, this is an exterior point, these are the two tangents and the two tangents are equal. This is an exterior point, BQ is equal to BR and we have this statement. All the tangents are equal from the exterior point, right? So, AB plus CD plus EF. What is this? AQ plus BQ plus CS plus SD, EU plus UF, that is equal to AP plus BR, right? So, we have plus CR plus DT and ET plus FP. So, what we have is AP plus FP, BR plus CR, DT plus ET. Adding these three, what we get is AF plus BC plus DE. This is what? This is what we had to find. AB plus CD plus EF is equal to AF plus BC plus DE. This is what we had to prove. I hope this is clear now, everyone. Let us move to the next question. Example 10. If AB is a chord of a circle with center O, AOC is a diameter and AT is the tangent at A as shown in the figure, prove that angle BAT is equal to angle ACB. Let us see the proof. Since AC is the diameter, this is the diameter, right, and this forms a semicircle. This is a semicircle and this is an angle in the semicircle, right. So, this angle is 90 degree, great. So, this angle is 90 degree. What is this? Angle ABC is 90 degree. So, triangle ABC is a right angled triangle. What we have is angle CAB plus angle ABC plus angle BCA is 180 degree. Again why? Because angle sum property, angles in a triangle are 180. So, angle CAB plus angle BCA is equal to 180 minus 90. This is why. Why? Because angle ABC is 90. So, which is 90. Since the diameter of the circle is perpendicular to the tangent, again this angle, this complete angle is 90 degree. So, what we have is angle CAT, this is 90 degree. Now, angle CAB plus BAT is 90 degree, right. So, from equation 1 and 2, this is equation 1 and this is equation 2. What we have? CAB, BCA, BAT. So, we have CAB plus angle ACB is equal to angle CAB plus angle BAT, right. So, what we have is angle ACB is equal to angle BAT. Why? Because angle CAB and angle CAB cancels with each other. I hope it is clear. Students, I hope all the questions and all the examples, concepts are clear from this session. Please practice questions from NCERT textbook. Thank you.